Hello everyone. As discussed in last video about gauss method, there is another advanced iterative method which is advanced than the gauss method, which is called gauss-seidal method or gauss-seidal iterative method. As we know that all the power load flow problems are to calculate magnitude. The all load flow problems are to find magnitude and phase angle of the load bus voltages, reactive power at the generator buses, real and reactive power flow in the transmission line. Also, when the load is increased, whether we can facilitate the load using our generators and the available network of the power system. Using digital computation, it is a requirement of electrical engineer to find out whether it is permitted by mathematical computation or not. So, as we need to solve number of nonlinear algebraic equation, so one of the method proposed is Gauss-Seidel method. So it is a iterative algorithm to find out the set of possible solutions. Here the vector should converge within the permissible limit with prescribed accuracy. If we able to achieve, means the system comes to steady state under given conditions. So there are one slack bus and n-1 buses are PV buses where the voltages and angles are assumed. So this is the first point. Assume a flat voltage profile for all buses except the slack buses. Then we need to initiate the iteration count k equal to 0. Then set bus count to 1, that is I. Check for the slack bus. If it is a slack bus, then we need to go to step number 16. Otherwise, we can go to next step. If the bus is not a slack bus, then check for generator bus. If it is generator bus, go to next step. Otherwise, go to step 12. Temporarily replace the magnitude of the assumed voltage magnitude by the specified voltage magnitude. Keep the phase angle same as that iteration. Go to next step. Compute the value of Qi by submitting most updated value of the voltage. Now check whether the calculated reactive power lies within the specified range or not. If it violates the limit, go to next step. Otherwise, go to step number 3. If calculated Q is less than M minimum, we set M min. If calculated Q is greater than the max value, we set to max. In this case, generator bus is treated as PQ bus and compute voltages. Step number 12, compute voltage. If Q lies within the limit, compute and update the specified voltage. Calculate change in the magnitude of the bus voltage between two consecutive iterations. Go to next step for the load bus, otherwise go to step number 16 for generator bus. Calculate more accurate values of voltage by considering acceleration factor. The acceleration factor is to speed up the iterative process. When the convergence is going into incremental thing, so to get the gradient, so we can use acceleration factor so that we can achieve the convergence in the less number of iterations. Now advance bus count to I equal to I plus 1 and check all buses are considered or not. If all buses means I equal to 1 to n, if n network system is there with n buses, then all n buses we need to compute the value of delta V. So if all buses were considered, go to next step. Otherwise, repeat from step number 6. find out the largest of absolute value of the change in the voltage. If this value is less than the pre-specified tolerance, go to next step. Otherwise, go to step number 5 by increasing the iteration count k equal to k plus 1. Evaluate the line flows and slack bus power and print the voltage and the line flows. So this is the Gauss iterative method. So in this Gauss iterative method, here current we will find out, for example I subscript I we can find out, which is Pi minus jqi by Vi star. Similarly Vi star, here we need to find out with the formula 1 by y ik Pi minus jqi by Vi star minus sigma k equal to 1 to n yik vk. So using this general formula, we can compute the value of V, and every iteration we are finding delta V. So here PD and QD are known, and we need to allocate PGI, QGI to all generator buses except the slack buses. We need to compute the admittance matrix before starting this Gauss-Seidel method. Then we need to compute value of Vi. So Vi is Vi magnitude I e power I delta. So this is the Gauss-Seidel method. So the difference between Gauss method and Gauss-Seidel method: in Gauss method, when we are computing value of delta V, so we will be using the last iterative value of Vk and Vk plus 1. But here when we are computing various parameters, powers, active power, reactive powers and voltages, we will replace the value of voltages by the latest known voltages to that iteration. So by using the latest voltages available for that particular iteration, this will have a speedy convergence. So if you compute with Gauss method and Gauss-Seidel method, the possibility of getting converge in the accurate given specified limit is more in Gauss-Seidel method than Gauss method. And also there is the acceleration factor. So by using acceleration factor also, we will get Gauss-Seidel method convergence in less number of iterations. And in the next video we will be discussing Newton-Raphson method. In the Newton-Raphson method, we will be calculating Jacobian matrix. So to compute the Jacobian matrix by the computer requires more computation things, but the number of iterations in the Newton-Raphson method are less compared to the Gauss-Seidel method. Where in the Gauss-Seidel method we have more number of iteration, but each iteration have less computation. So in that way, for small systems, Gauss-Seidel method is preferred. For the larger system, Newton-Raphson method is preferred. Thank you for listening.